Welcome back, MEFB 2132013 manufacturing processes. So today we're going to talk about a new topic, Unit 5, contemporary or modern casting processes. So if you remember in the last chapter, we spoke about sand casting, whereby our mold was constructed from sand, in specifically silica sand. And if you remember the terms we use, scope and drag, disposable pattern, removable pattern. Yeah, so all this was part and parcel of the construction of the mold. I also, if you remember correctly, yeah, it was a very tedious process where it involved several stages where first of all you need to test the mold. First of all you need to mix the molding sand with additives. Yeah, you mix the molding sand with additives, and then to harden or strengthen the sand, and then the sand undergoes several testing methods in order to ensure that the sand is usable. And once it passes the test, then you start constructing your cope and drag. Construct the cope, construct the drag, calculate the gating system, construct the gating system according to the dimensions, and then you are going to overturn the cope onto the drag. And once everything is in place, you're going to melt the metal. Okay, once you have the molten metal or liquid metal, you can slowly open up the mold and remove the removable pattern that is inside. Close up the mold, and then you're going to pour the liquid metal through the pouring basin, which will eventually flow through the gating system and enter the cavity. It will fill up the riser first and then the cavity. If there's shrinkage, then metal will flow from the riser to compensate the shrinkage in the cavity. Allow it to solidify. Once solidified, the part will be removed. How do you remove the part? You need to break the sand and then remove the part. So like I mentioned to you, sand casting was a very, very tedious process. So in this chapter, we're going to look at metal casting, modern casting, or metal. So meaning that your mold is all pre-ready made. Okay, so it's a machine and you have metal molds in order to in order to do the casting process. So what is metal mold? Metal molds are made of special metals that withstand high temperatures of the molten material. It's used to produce large number of castings and is used to produce small and medium size castings. Yeah. So die. What is a die? Die is a metal mold. Okay. Die for hot and cold chamber machine are similar in construction. Dies are made into two halves which allow casting removal. So similarly, like sand casting, here the metal molds are also made in two halves, but here we do not call it the cope and drag. We call it the two halves of the mold is called the movable half and the stationary half. So normally in a die casting process, the metal enters the stationary half when the die is closed, and when the die opens, the ejector pins for the casting will fall from the die and the part will be ejected. So I will explain this in detail shortly. So die or metal mold is much better than sand casting, because in sand casting you need to keep reconstructing the cope and drag over and over again. Here you already have a ready-made metal mold, and you can reuse the mold over and over again without having to construct anything from scratch. And moreover, the most important thing about this die is it has a very long lifespan. Okay, the lifespan can range between 10,000 filling or 10,000 parts for brass to several million parts that can be produced when you use zinc as the base metal to make the mold. Okay, similarly to sand casting, in die casting or in metal die is metal mold. So in die casting, vents also should be considered to allow the gases to escape. Okay, and dies are provided with water channels to cool the die after injection to metal. Okay, so instead of waiting for the die to cool for the next part, it's going to be, the entire system would be immersed in a water chamber okay, or water channel to cool the process and to prevent the machine from being damaged. Okay, so die casting, like I just mentioned to you, die is a metal mold into which molten material is forced to fill the cavity of the mold. And die casting is accomplished using two methods. One is hot chamber, two is cold chamber. What is hot chamber? What is cold chamber? So you have the hot chamber die casting, cold chamber die casting. Why? What's the meaning of hot and cold, yeah, in this context? So let's look at it. So hot chamber method. In hot chamber method, molten pot is included within the machine. What is a molten pot? Molten pot is a furnace. What is a furnace? A furnace is a place where, or the location where you melt the metal. So an injection cylinder is immersed in the molten material at all times, and the injection cylinder, which is actuated by air or hydraulic pressure, forces the molten metal into the cavity. So what do I mean by that? Let's look at this diagram. So this is a typical metal mold, okay, or hot chamber die casting. So when I said, or when I mentioned to you that the molten pot is located within the system, this is the molten pot. If you see, this is the molten pot. Okay, this is the molten pot. Molten pot is where the metal is melted and the metal remains in its liquid stage here. So like I previously mentioned to you, this is an injection cylinder. So how do you push or force the molten metal into the cavity? You in die casting, you're going to use an injection cylinder. So this injection cylinder will always be immersed in the molten metal. So for example, if this metal is aluminum and the melting point of aluminum is 900 degrees Celsius, meaning that you must maintain 900 degrees Celsius throughout the process. So each and every part in this machine will be exposed to 900 degrees Celsius. Therefore, each and every part in this machine has to be made of heat resistant material. Otherwise, the machine will damage very quickly. Okay, so back to the topic, you have the injection cylinder or injection pressure. More specifically, we're going to use hydraulic pressure to push the liquid metal into the cavity. So this is your liquid metal and this is the furnace where you have melted the metal. This is your injection cylinder. This is the gate. Okay, this is the gate through which the liquid metal will flow and it will enter the cavity. So this is your injection cylinder. This is your furnace where the metal is being melted, and the injection cylinder will force the liquid metal or molten metal through the gating system and it will enter the cavity. This is your stationary half. This is your movable half. So as I told you, the mold has got two halves, stationary half, movable half. So when the liquid metal starts filling up the cavity, if this cavity can accommodate 5.1 liters, only 5.1 liters is allowed to fill up. Where at 5.1 liters exactly, the gate will shut and the mold will close. Okay, so if you're applying a hydraulic pressure of 35 megapascal here, you're going to apply an equal and opposite pressure from this side, okay, of 35 megapascal. Why? You need, during the solidification process, you must apply an equal and opposite pressure to make sure that the metal is evenly distributed within the mold. If there's only pressure being applied from one side, then you'll have metal concentration on only one portion of the mold and you'll have an uneven part. So to ensure an even densification and even distribution of metal, you need to apply equal and opposite pressure. How much of pressure? Again, it depends on the size of the part. So the larger the part, the more pressure is going to be applied. So normally pressure will vary between 35 megapascal to 275 megapascal. So once the mold is filled up with liquid metal, the mold closes, equal and opposite pressure on both sides, solidification process starts. So, for example, if it takes 25 minutes for it to solidify, exactly at the 25th minute, the moment solidification is complete, release pressure, the movable half of the mold opens up, the ejector pins will eject the casting, and the casting will be dropped off. Okay, so the casting will cool down in room temperature. Okay, it will cool down in room temperature. So then it's ready for the next round or next part. So if you look at it precisely, if it takes 25 minutes for solidification, the entire process itself may only cost you about 30 to 35 minutes from the time it started until the liquid metal flowed into the cavity, mold closed, apply pressure, allow solidification. Once solidified, release pressure, open up the mold, right? So as compared to sand casting, where you need to construct the cope, construct the drag, test the sand, so many tedious processes. So the same exact part that you produced in a sand casting can be produced in die casting in a much shorter period of time. That's it for this slide. Thank you, class.